So we're actually going to be applying everything that we've been doing to word problems. These are basically physics problems. Is anybody in physics right now? Okay, so Cole will recognize these. When you get to physics, these are the types of problems that we're going to be doing, okay? So, example 1, we're throwing a ball. Now, like I said, you don't have to write the problem, just the formula and what everything stands for. Jason is standing on the ground and throws a ball vertically upward with an initial speed of 80 feet per second. His height after t seconds is given by this equation. So here's the equation.
That's not the right.
Okay. H is your height. T is the time in seconds. Okay. So H is your height, T is the time in seconds. Okay, so I always draw, and partly because it helps me kind of see the parabola and what's going on. So let's draw Jason. He's going to be standing on the grass. And I use colors. Okay, so the grass or the ground is going to be my x-axis. Here's Jason. He's going to wear a baseball cap. And let's make it a baseball that he's throwing. So here's the baseball. Or a softball, it looks more like. Kind of large. Okay, so he's throwing a ball. And when he throws it, it arches up before it actually starts coming down, right? And it has a maximum point. There is a point when I am throwing the ball that it reaches before it starts to drop, right? That's your maximum, or the vertex. Okay, so that's your maximum point right there. That one point, that's what we're looking for. And the maximum and minimum is always the same as the, starts with a V, vertex, okay? So let's look at part A. Part A asks me, how high does the ball go? What am I looking for when I'm being asked how high the ball goes? Is that the X or the Y? That's the, if the grass is my X, the height is my Y. So this is actually the Y value, right? And I don't like the way this is set up. I need to change it.
When we use the real problem.
In your homework, this is why I set it up this way, is because in your homework it asks how high the ball goes. We can't find the Y value until we have the X value, right? So we actually have to skip part A and come back to it later. Okay, so let's skip part A, and we're going to come back to it in just a second. So let's do part B. I'm just going to change the A to look like a B. So let's do part B first. How many seconds does it take to reach the maximum height?
7.
So what am I going to be looking for? The X value or the Y value? The X value. Because we can look at this X-axis as the passage of time, right? Here's where the ball was at 1 second. Here it was at 2 seconds. Here it is at 3 seconds, 4 seconds, 5, 6, 7, 8. Do you see what I'm saying? So the X-axis is actually our time. The Y, this right here, that's your height. So as time passes, the ball is increasing at first, and then it starts decreasing. So this is kind of like that widget problem. What point, what X value do I reach my maximum height? So I'm looking for the X value of the, starts with a V, ends with an vertex.
Velocity.
Vertex. Okay, so I'm looking for the X value of the vertex here. That's going to be X equals negative B over 2A. You're going to use this a lot for these word problems. Okay. I'm looking for which point in time does my ball reach the maximum height in the air. Okay? So that is going to be negative b. Which one is b here? Negative 16 or 80? It's actually 80, because in this version, they put the squares last. So it's actually going to be negative 80 over 2 times negative 16. I know, it's confusing.
Wait, wouldn't it be negative 16?
So that's negative 80 over positive or negative 32. This is actually going to give me a fraction that's not uncommon. So let's reduce this fraction. What goes into both 80 and 32? 16? I don't think 16 times anything goes into 80. I think it's 8. Oh no, 16 does. 16 times 5. So if we divide everything by 16, that's going to give me positive 5 over 2 by negative 16, yeah. Okay, obviously seconds doesn't look like this, right? How can I rewrite this in seconds? 2.5 or 2.5. So this point is 2.5 seconds.
You're not accounting for gravity.
Okay, so at 2 seconds the ball reaches its maximum height. So now can we answer part A? What is the maximum height? How do I answer it? Yeah, plug 2.5 in. So let's do h equals, you can use either one, the rewritten or the original. 80 times 2.5 minus 16 times 2.5 squared. You may use calculators on this. So, just because I have all of the math already done, that gives me an h of 80 times 2.5 gives me 200. Minus 16 times 2.5 squared gives me, 2.5 squared is 16 times, what did I say, 6.25? No. 6.25. So that's going to be 200 minus 100. So that gives me a height of 100. Is it in feet? Yes, feet. Okay, so at 2.5 seconds, our ball reaches 100 feet. Okay, so that's my maximum point. Part C is a little bit tricky. Part C says, when does the ball hit the ground? What do I know about when the ball hits the ground? Do I know what time the ball hits the ground yet? No, that's actually what they're asking me. Do I know what the height is at ground level? 0. Height is 0 at ground level. So what do you think we have to do? Take this equation and plug in 0 for h. So we have 0 equals 80t minus 16t squared. We are looking for the x-intercept. So how would I solve this? This isn't a perfect square. Do you guys see a GCF of 16? 16 what? T. So pull out a 16t, and that leaves me with 5 minus t. Set each one equal to 0, so 16t equals 0. 5 minus t equals 0. If I divide both sides by 16, that gives me t equals 0. Or I can subtract 5 or just add t to both sides, because then that gives me 5 equals t. Okay, one of my answers does not make sense. Which one? T equals 0. That means I haven't even thrown it yet. I'm looking for the time that it hits the ground. So it hits the ground at 5 seconds. In example 2, we're shooting an arrow upward with initial speed of 96 feet per second. The height after t seconds is given by this equation. H equals negative 96t minus 16t squared. Now this does not look like what we wanted it to. Usually we have the squares in front, so I'm just going to rewrite it so that it helps us later when we're looking at A's and B's for the x value. And then part A asks, how high does the arrow go? So when we're shooting an arrow, let's say that we are standing on the grass. Here's my archer. Let's make him Robin Hood. With his little feather. Okay, and he is shooting an arrow. Okay, that arrow's going to go up and reach a peak point, and then eventually it's going to start falling. That peak point, my max, is what I'm looking for. Okay, that's also the vertex of your parabola. As time passes, that's our x-axis, and the height is going up and down. So as time passes, my height is changing. It reaches a peak point, and then it starts to fall, but time is still passing. Here, when it hits the ground, that's when our height is equal to 0. So let's start looking at the problem. How high does the arrow go? We can't tell what that maximum height is until we know what time it reaches its maximum height. So we're going to answer part B first. We're just going to use our good old formula, x equals negative b over 2a, to give me negative 96 over 2 times negative 16. So that's going to give me negative 96 over negative 32. So my t is going to be equal to 3 seconds. So at 3 seconds here, that's when I reach my maximum height. This is 3 seconds. Okay? So now I can use that 3 seconds and plug it back into h. So h is equal to negative 16 times 3 squared plus 96 times 3. I just plugged t into this equation. That gives me negative 16 times 9 plus 96 times 3. So h is equal to negative 144 plus 288, which thank goodness gives me a positive 144 feet, since we can't have negative feet. So at my 3 seconds, when my ball reaches the peak, it's actually at 144 feet. So then part C asks me, when will the arrow hit the ground? So that's when is the height equal to 0. So I'm going to plug 0 in for h. So 0 equals negative 16 t squared plus 96 t, and I need to factor that. I have a GCF of 16 squared. So let's pull out 0 equals negative 16t. I'm sorry, my GCF is negative 16t. And that is going to give me
Kendra Randall, please report to the Sierra office.
When I pull out a negative 16t, that leaves me with t minus 6. And then I can set each one of these equal to 0. So negative 16t equals 0, and t minus 6 equals 0. Divide both sides by negative 16, and I get t equals 0. Add 6 to both sides, and t equals positive 6. Now, I'm looking at the end result here. When does it hit the ground? So t equals 0 doesn't make sense. So my arrow actually hits the ground at 6 seconds. Last example, example 3. We're throwing a frisbee, but this time we're not doing it from the ground. We're doing it from the balcony of a building that is 64 feet tall. The height h of the frisbee after t seconds is given by this equation, and this actually looks like what we want it to look like. T squared, t, no t. So we're good there. Part A asks, how high does the frisbee go? Remember, the height is our y value, so we can't answer that until we know what the x value, the time. Okay, so I have to answer part B first. How long until the frisbee reaches maximum height? That's asking me what is the x value of the vertex. So I'm going to plug it into negative b over 2a. So that gives me negative 16 over 2 times negative 8. So that's negative 16 over negative 16. So I reach maximum height after only 1 second. And then my frisbee starts to fall. So part A, how high does it go? So after 1 second, how high is the frisbee in the air? H is equal to negative 8 times 1 squared plus 16 times 1 plus 64. So that gives me negative 8 plus 16 plus 64, which is 72 feet. So 72 feet is my maximum height. After 1 second, it's going to be at 72 feet, and then it starts to fall. So then part C, when does the frisbee hit the ground? When the frisbee hits the ground, that's when x equals 0, or h equals 0. So we set the whole equation equal to 0. Negative 8t squared plus 16t plus 64. And there's a GCF in here. So before we go straight to bottoms up, let's factor out a negative 8. That's going to leave me with t squared. That's going to leave me with t squared minus 16t minus 2t minus 8. So I'm looking for two numbers that multiply to negative 8 and add up to negative 2. That's negative 4, positive 2. So this factors to negative 8 times t minus 4 times t plus 2. Let's set each factor equal to 0. So negative 8 equals 0, t minus 4 equals 0, and t plus 2 equals 0. Negative 8 equals 0 doesn't make sense, so we can throw that out there. Let's add 4 to both sides, so that gives me t equals 4. And then subtract 2 from both sides, and we get t equals negative 2. And so now we have two options for our time, when the time is 4 seconds and when the time is negative 2 seconds. I have never been able to reach negative 2 seconds. It does not make sense. So our only answer is that the frisbee hits the ground at 4